Hello, my name is Lisa and today I'll be explaining Euler's method. So let me share my screen. Okay, so here is our graph explaining Euler's method. So let's say we are given the differential equation of dy over dx is equal to fx comma y bracket. So by plotting our tangent line, we can know that tangent is equal to y over 1 and we can figure out the next point. Yeah. And so since tangent is y over 1, our 1 is our h, which is also equal to our step size, and our question mark is our increment of y. And so by manipulating the formula, we can multiply h up to find our question mark, which is also equal to increment of y. And so h multiplied by f x0 comma y0 is to find our y. So at x0 equal x0, so this is our initial condition. And so when x1 is equal to x0 plus h, which is here, plus h as you can see, and y1, which is here, is also equal to y0 plus h multiplied by f x0 comma y0. So what is f bracket x0 comma y0 is also here. To find fx comma y is also equal to x squared plus 1 divided by y. And then so we can keep on doing it. And so we can always repeat it until we get until our wanted answer. Yeah. So the smaller the set size will make the answer more accurate. So in the question, they wanted us to find dy dx is also equal to x squared plus 1 divided by y. So when y is more than 0, given the initial value of y bracket 0 equal 1, so when x is 0, y is equal to 1 for initial value. And they want us to find the approximate value of y when x is equal to 1. So for this, our step size will be using 0.1. And so this is our initial value of x and y, which is 0 and 1. And for this, to find this, we will use x squared plus 1 divided by y to find our f x0 comma y0. So here, as you can see, to find our y1, we will use y0 plus h multiplied by f x0 comma y0. So this is our y1. As you can see, we're using d4, which is our y0, our initial y, plus h, which is our step size, multiplied by our f x0 comma y0, which is 1 from here. And so we can keep on doing it until our x is 1, as they want us to find y when x is equal to 1. So when x is equal to 1, our answer for y is 1.911375059. Okay, so for here, this is our general solution. So by multiplying y to each side, by multiplying y to dy and dx to x squared plus 1, we can integrate them to find c. So to find c, we sub in our initial value, which is when y is equal to 0 and x is equal to 1. I mean, when x is equal to 0 and y is equal to 1. So from that, we can get our c is half. And so to find our new y, when x is equal to 1, is we sub x back into the formula. So from that, we can get our answer, which is y is equal to 1.9148. Yeah. So as for approximation error, is we use our general solution minus our Euler's method is also equal to 1.9148 minus 1.911375059, which will also give us to 0.003424941. Yeah. So that's it for my presentation, and thank you.